Alright, time for another DraftPhysics.com video presentation. So, response of sorts to physicist Michael. Get to it in a minute. Alright, I'm back. Like that better. Anyway, so he's talking about relative KE measurements. Now, the bottom line is he's basically conceding that in all frames of reference, whatever you call those, fuel has to be fuel, has to be fuel, has to be fuel. So no matter what observers are seeing, the gas tank level has to always be the same in all frames. Gas tanks can't lose fuel at different rates in a different frame. So he's defending that position that yes, it is always going to be the same amount of fuel used, I think. But it's all kind of contrived mathematics, frankly. That's what I'll call it. It's this idea of switching quantities or constants even for some other formula. And so they just keep putting different formulas where the numbers are until they get the number they want. Yeah, frankly. Instead of actually just solving the math. So, I mean, there is a perfect example of it in here. I frankly think this is just shenanigans. So there's oftentimes they'll say KE equals, KE equals, KE equals, and they keep changing the formula. So they keep switching out pieces of the formula and saying, well, this portion equals this other formula, so I'll stick this other formula in that place. And then they stick some other formula in for some other amount. And frankly, in this example, he could solve for the formula right here. And the fact is, if he solved the equation, this equation, he'll get a different answer than if he solves the third equation. Down here, sorry. This equation, if he just solves it, he'll get a different answer than if he solves the third equation. They're supposed to be equal. They're supposed to be the same thing, but they're really not. So, I just call that, crapomathics. That's just... Frankly, in my opinion, it's just kind of a cheat or dishonest. It's just not right. A formula can always agree with an answer, right? You can get two formulas and they'll say for certain variables in certain circumstance, they'll come up with the same answer and say equals 1. But if you change the numbers, then they'll diverge and one formula won't get the same answer anymore. So you can't use them as replacements universally because they only got the right answer in one circumstance. It's only in one circumstance they equaled the same thing. They don't equal the same thing in all circumstances. So anyway, I just think it is, my personal opinion is it's junk math, but whatever. I really think the whole point is to argue the conclusion, which is the part that's really wrong and unproven and I think is really bad physics. So we'll get to that. Pen, where are you? Here you are. Alright, so first I shall explain a way of doing this. Now I argue he decides to turn these into cars rolling on the earth. So he's creating a third object where he can, basically... It's like when they create extra dimensions. It's a place to shove the energy. It's a place to create these relative differences. But frankly, you don't need to do that, or you shouldn't do that if you really want to take the argument seriously. So the argument really has to do with, you have a spaceship that from the perspective of the person driving, he's not moving. And he sees another spaceship coming towards him, okay? He doesn't know whether he's moving or the other guy's moving. It's coming towards him at 10 miles an hour because this guy's actually going 10 miles an hour and he doesn't know it. But let's just leave that alone. This guy decides to apply a engine thrust of 10 miles an hour. So now they're both flying the same. So from this guy's perspective, that guy's going 10 miles an hour. Because that's the only way he could undo his reverse direction is to go forward. So he's now applied thrust. And the point is that because of their KE rules, that it takes 3 times the thrust to go from 10 miles an hour to 20 miles an hour than it took to go from 0 to 10. So 0 to 10 takes 1 unit of force. 10 to 20 takes 3 units of force. 20 to 30 takes 5 units of force. 30 to 40 takes 7 units of force. And these numbers are even more preposterous in the sense that they're basically arguing that if you want to go 4 times faster, you have to expend 16 times the fuel. 16 times. So they actually think that's real. Now, even though we don't have any physical evidence that that's real, they think it's real. And so it's part of this. So his answer is, he produced the answer, okay, mathematically. But I would argue that the only way he produced it was creating this, artificial circumstance of pushing on the Earth. So if you really went by just exhaust, that is, they are exhausting photons. Let's say they're exhausting photons to move. So they're sending something going the speed of light. And that's the fuel, photons. So that's what gets expelled. So obviously, if the fuel doesn't hit an Earth or hit something, then you can't make these arguments that there's a whole bunch of hidden energy somewhere. There's just the photons leaving the ship, and they're only going tiny velocities, 10 miles an hour. Okay, it's not there. There's no relativity argument you can make. Their speed is so much lower than the exhaust speed of their fuel. So there can't really be too many confusing elements here. How many photons does it take? And the argument is that if it takes 100 photons to do this, it's going to take 100 photons to do this. That is, for this ship, when they're both going the same, 0 from this guy's reference, and this guy stopped moving the other way. I said it the wrong way before. What this guy sees is this guy's moving towards him, and he stops that velocity to go 0 to be doing the same thing this guy's doing. So they both could be thinking they're going no miles an hour, but they're both going 10. And so how many photons are going to have to shoot out of this rocket for it to go what looks like 10 more miles an hour? Because are they really going 30 to 40? Are they really going 20 to 30? Are they really going 10 to 20? Which one are they really going? And the fact is, none of this stuff happens. It takes the same amount of fuel per increase in velocity. It takes twice the fuel to go 20. It takes 3 times the fuel to go 30. It takes 4 times the fuel to go 4. I said 3 times for 30, 4 times for 40. All of this is a mistake, and it's all based on the original mistake, which was Leibniz's mistake of misunderstanding gravity. Gravity gives you that 4 times the dropping distance, but it turns out that it's only twice the time in the gravity. 1 unit of time, 2 units of time. You only have twice the energy when you hit the ground here. That's all you have. But you're only in the gravity twice as long. You're only collecting 2 units of force. That's all you have. You don't have 4 units of force. Alright. So that original mistake, you can see it in all of these other things. These are Galileo's numbers right here. 1, 3, 5, 7. Galileo pointed out all this stuff. He pointed out quite clearly that, set the groundwork for understanding that the force is only 2 units. 2 units of time. And that's what matters. How long you're in gravity. So again, I don't want to... Well, I might as well throw it in. I mean, it's just kind of obvious. I have a gravitational surface, and I'm going to fly by a fixed distance. The faster I fly across this distance, the less the gravity will affect me, because I'll be in it less time. So it's all dependent on how much time you're in the gravitational field will decide how much gravitational force you collect. In it very long, you're going to hit the Earth. In it very little, going very fast, very little bending. Alright, so that's probably enough of a premise. Yeah, I see if there's anything else I need to say to, solidify the argument. Alright, so I figure I might as well add the weight, the consequence of stuff falling, and the scale, kind of basic argument. So what they say is when you compress a spring twice as much, you store 4 times the force in the spring. So I can put a 1 mass on a spring and it only takes 1 unit of energy, 1 unit of force. And then when I put the same exact mass and do the same exact work, somehow putting a second object on the scale, I gained 3 units of force, even though I only had to do 1 unit of work. So 2 units of work equals 4 units of energy. That's what they're saying. That's the same thing. 2 units of work equals 4 units of energy. Twice the compression of the spring, 4 times the energy, even though it only takes 2 units of work to create twice the compression. Again, does it make any sense? I put the first one on, I only put 1 unit of force. Somehow when I add the second one, do exactly the same work, I added 3 units of force. Doesn't make any sense. Can't make any sense. But they just assert it, they don't really show it. So that's the bottom line here. So in all of this, 35-minute video where he says that in all frames you have to use 3 times the energy to go from 10 miles an hour to 20. Even though in the relativity argument itself, you don't know whether you're going from 80 to 90 or 30 to 40. You don't know which one you're actually doing. Because depending on the frame you're in, you can be doing almost any number. You could be going from 500,000 miles an hour to, 500,000 miles plus 10. You don't have any way of knowing how much you're increasing at what actual velocity you're actually increasing, which means there's no way to predict how much fuel you need, except the fact that, either relativity has to be killed or you have to kill this kinetic energy theory and recognize that fuel is fuel is fuel is fuel and force is force is force is force. And it takes exactly the same amount of added force to compress the spring twice as much. 10 pounds plus 10 pounds equals 20 pounds, twice the compression. It only takes 2 units of force to go twice the speed. It only takes 3 units to go 3 times the speed. It only takes 4 units to go 4 times the speed. Not 16. All right. So they have no experimental evidence in any real experiment. That is, they don't have any example where they can show you it happening with a turbine or a generator or a motor or a car or anything where they can show you it taking 16 times the fuel to go 4 times faster. And the numbers get more and more ludicrous. And what I can show you is things where it's exactly the opposite, where a NASA launches a rocket and the more fuel they put on the rocket, that is, the higher the distance they shoot for, the better and better the fuel economy gets. So the faster they go, the less fuel they use. First, because they're fighting less gravity, because they're in the gravity less time, but also because it's just a fact that you don't lose anything by going faster. It doesn't take more fuel to go faster. All right, it takes the same amount per unit of distance and such. So yeah, no evidence, no physical evidence. They just assert this to be a fact, and on its face, the assertion, again, you really believe it takes 16 times the fuel to go 80 miles an hour instead of 20 miles an hour. 16 times more fuel going 80 miles an hour than 20. Come on. Too silly, right? Okay. Anyway, so yes, we'll leave it there. So that's my response. And it's unfortunate that he has now thought this question was more important than all the questions I've asked. So I've asked him to explain how it's not 9.8 meters per 1 second. I've asked him to explain these different paradoxes created by their theory. Instead, he wants to talk about some highly obscure relativity question where his answer is basically just to make an assertion, okay, that frankly there's no physical evidence that it's true. That it takes 3 times the fuel to go from 20 miles an hour to 30 miles an hour versus going 0 to 10. All right, enough said. So, till the next time and such, and so forth and whatnot.